By the by, I have to, okay, in between I will just write the names of the people here. Lina, Shahena. Mosina, Nora, Rishina. Then who is there? Ledida. ഒരാളെ എനിക്ക് കിട്ടിയിട്ടില്ല എന്ന് പറഞ്ഞു. ഹർഷ എഴുതിയോ? ഹർഷ എഴുതി. 1 2 3 4 5 6 7 ഇനിയുണ്ടല്ലോ ആൾക്കാർ, 8 പേര്. ഇനി ആരാ ഞാൻ എഴുതാത്ത 4 പേര് പറഞ്ഞ്?
ഹിബ.
ഹിബ. പിന്നെ ആരെങ്കിലും? I think it is complete. Okay, right. Now let me, I was telling you the reaction. CH3, CHOH, CH3, a secondary alcohol, reacting with NaOI, giving you CH3, C double bond O, CH3. Okay. Then this again reacting with 3 molecules of NaOI gives you Ci3, C double bond O, CH3. This is treated with sodium hydroxide. I think the mechanism we have written yesterday. The mechanism we had written yesterday. Okay, and we get Ci3H. This is called iodoform. It's a yellow solid. Yellow solid. As an insoluble precipitate, yellow solid or precipitate. So this can be used as a technique. This reaction, iodoform reaction, this reaction is used to identify the presence of a group like this in a molecule. This group or this group. In a molecule, in an organic compound. That means a methyl ketone or methyl secondary alcohol. A ketone, that is a ketone or a secondary alcohol a terminal methyl ketone or a secondary alcohol. Can be identified by this test. Okay, so this is that reaction. This can be identified by this test. Now let's look at the reaction of alcohol with acids, halogen acids. Suppose you have an alcohol reaction with halogen acids. Say for example, if you are taking ROH and reacting with HCl in presence of zinc chloride, you will get RX plus H2O. Now, what is the role of zinc chloride? Zinc chloride is used as a dehydrating agent. What is a dehydrating agent? Removal of water. Removal of water. So that, see here, the moment this water molecule is formed, it is taken away by zinc chloride. And therefore, the reaction shift towards the product side by Leach-Hartley's principle. Okay, this you must have already studied. So the reaction shift to the right hand side by Leach-Hartley's principle. Now, let us now this reaction is the rate of reaction is different. The rate of reaction is different for different compounds. Okay. Now the order of reactivity. The order of reactivity. The order of reactivity is tertiary is faster than secondary, faster than primary. Okay. Meaning, if you take a test tube, take a test tube, or rather take 3 test tubes. Into this you add tertiary alcohol. Into this add secondary alcohol. And into this you add primary alcohol. Now, each of them you add HCl plus zinc chloride. Okay. To each of them you add HCl and zinc chloride. And then your observation will be, you will observe this is test tube number 1, number 2, and number 3. Turbidity appears turbidity appear instantly in test tube number 1. What is the result? Tertiary is fast. Now, what is it? Turbidity. What is the turbidity? See, this is your tertiary alcohol. Look at the tertiary alcohol we have taken. Tertiary butanol we have taken. This is reacting with water. HCl, sorry. HCl. This is reacting with HCl. Okay. What you will get is C, CS3, CS3, and CS3 plus and Cl minus. This is reacted very easily with Cl minus, and you will get. And this is water insoluble. Water insoluble. This is water soluble. At least partially water soluble. So since it is water insoluble, it appears as turbidity. Okay. So this is the reaction with tertiary alcohol. In the case of secondary alcohol, the reaction rate is less. So a turbidity will appear after 5 minutes. Test tube number 2. Turbidity appear after 5 minutes. Okay. And in the case of tertiary alcohol, as a primary alcohol, that is test tube number 1, no turbidity at all. No turbidity. Okay. So this is, remember this is done at room temperature. We are not heating it. So at room temperature, there will be no change. This test is known as Lucas test. Lucas test. To distinguish between primary, secondary, and tertiary alcohol. Okay. So we have seen 2 tests for alcohol. In this, we have studied 2 tests. Number 1, hydroform test. What's the use? To identify this group or this group. Test number 2, Lucas test. Distinguish between primary, secondary, tertiary alcohol. Is it clear? So that is, so these are the tests. And let me just check whether you have Now, in between, we have something called chemistry of methanol poisoning. Okay. Now, see here, when we, I have already told you, for people who are having the drinking habit, people having the drinking habit, the 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 usual alcohol which is marketed is contaminated with methanol. So what happens is the methanol will also get methanol will get oxidized in methanol will get oxidized in the alcohol and will form formaldehyde in the body by what is called alcohol dehydrogenase CH3OH, which is present in alcohol, which we have added in alcohol. When we consume, this will be reacted by the enzyme alcohol dehydrogenase. Alcohol dehydrogenase. And will be converted into HCHO. This is what is called formaldehyde. And remember, this will be further oxidized into formic acid. Okay, both of them, formaldehyde as well as formic acid, they are very toxic. And they will inhibit mitochondrial cytochrome. Mitochondrial cytochrome. So it will affect your mitochondria. Mitochondrial cytochrome oxidase. Cytochrome C oxidase. This is an enzyme which is working with which is working in the mitochondria, and this will cause depletion of oxygen. It will cause depletion of oxygen. Depletion of oxygen at the cellular level in the cells. Okay, and this will result in generation of excess acid in the body, resulting in the generation of excess acid in the body. Okay, this will result in the generation of excess acid in the body, and this will cause and thereby causing a lot of metabolic disorder, causing metabolic disorder. And also it causes visual disability. What is meant by visual disability? Your eyesight will be lost. Your eyesight will be lost. Okay. So this is the effect of methanol poisoning. Okay. Right. Now a few other reactions of alcohols which you should know. A few reactions more I want to give you. Say for example, I have got an alcohol like this. I don't know whether we have done it. SCH3. Suppose you have an alcohol. If I treat this with sulfuric acid, H2SO4. Or you take this compound, CH3, CCH3, OH, CH2, CH3. If I treat this with sulfuric acid, what will be the product of it? What will be the product of it? I think we have gone through it. Am I right? We have done similar reactions. Did not? Yes, we have studied this before. We have already studied this before. Anyway, let's see. Look here. Just think whether how many of you can write the answer to this question. Just try to at least keep in your mind. If you have some answer, please write it here in your book. Now let us discuss this: how to find the product without by hearting it. Now look at this molecule. This is a purely organic neutral molecule. Organic neutral molecule. Not very reactive at all. But look at this. This is a very strongly acidic substance. That means the reaction is highly acidic. So this is how you predict the product. Look very carefully. So we have an acidic medium, strongly acidic. What is an acid? It generates a lot of H plus in the reaction mixture. So we write an H plus here. Now H plus will act as an electrophile or a nucleophile. Quite naturally, you know, it acts as an electrophile. It acts as an electrophile. Okay. Now that means, what does it mean? Now when we write the mechanism, this is the meaning of what I'm telling you. This is your H plus. When we write the mechanism, there should be an arrow which is ending on H plus. That is important. You will have an arrow in the of mechanism which will end on the H plus. Because arrow, you know, arrow is formation of a bond from a nucleophile to an electrophile. Okay, so arrow means formation of a bond using a pair of electron. Now, from where this pair of electron will come, that is what we have to find out. Now, here is your molecule. Here is a molecule. Let me write the OH on this side, CH3. Makes no difference. Okay. Now, so quite naturally, there is no other place where you have pair of electrons. So I have got my OH. See that? See that? So I got CH3 and O, H, and H. Clear? This we are studying in fact under alkenes. And remember, you have got a positive charge here. You get a positive. Why do you get a positive? Because you have used a pair of electrons to form a bond with H plus. Don't forget to put charges. If I forget to put charges, I'll be totally confused. Now see here. This can be very easily removed. Why? Because the leaving group is water. You're going to form a water. Why this happen? This positive charge attract these pair of electrons to this. And you're going to get a very good H2O. And a positive charge. Now what is this? This is a carbocation. What type of a carbocation? Tertiary carbon. It is stable. Tertiary carbocation, we have seen it is stable. So, what happens? Now what happens? You have a tertiary carbocation, you have a proton here. Okay. And this water molecule, which has come out, will act as a base. Oh, why I should go like this? One second. I can take this proton, what is that? It gives you the same result. See this? Water molecule will accept the proton and will form the H plus again. Whatever H plus we have used here is coming out along with water. So this is a dehydration reaction. Okay. So this is a dehydration reaction. And please remember this dehydration reaction see here. We have generated this molecule, this carbocation, right? You can take this proton or this proton. If you take this proton, you will get this product. If you take this proton, you will get this product. So these are the two products. Okay. This is minus product and this is major product. We have studied this. This is what is called Zaitsev product. And this is Hoffman product. Zaitsev product is more stable. This is stable than Hoffman product. So this is less stable. So this is coming as a major product. Okay. Similarly, you can think of this, the one more reaction I have written. See this reaction, CH3, CH3, CH2, CH3. What are the products that can be formed? Just write down and see whether you can get the product. Simple reactions. Yeah. It is as simple as this. I can write it here itself. You can form the double bond either here at this point, or you can form the double bond here at this point. The formation of double bond here is the Zaitsev product, and this is Hoffman product. Okay, how will you distinguish between Zaitsev and Hoffman product? Zaitsev product is more substituted product. What is the meaning of more substituted? See here, this is one alkyl group, this is second alkyl group, this is third alkyl group, and here is H. So you have three alkyl groups across the double bond. But here, you look at this one, you have only two alkyl groups. This is one alkyl group, this is a second alkyl group. Both the other things are hydrogen. So when you have more alkyl group, it is more stable. Okay. So this is what is meant by a dehydration reaction. Okay. Oxidation we have seen. There are certain other reactions which you can think of. See, for example, you take, let us look at a few more reactions of alcohols. Suppose I have a molecule like this. Don't get scared of the molecule. You have to worry only on the product, on your functional group. Okay, big molecule may be there. Now this can be converted if you take this compound and react with a per iodo compound, per iodine. You will get this an exclusively this compound, CH2. See, this is what is called geraniol. It is present in rose water. The fragrant smelling compound is geraniol. This, when oxidized, you'll get geraniol. R stands for aldehyde. Okay. Now this is a specific iodine reagent, an iodine reagent, iodine oxidation agent, iodine containing compound. I don't want you to learn the structure of the compound, but it's an oxidizing agent. That's all. Okay. Now suppose you have an alcohol, a secondary alcohol. You have a secondary alcohol. See here. You have to look only at the functional group. Suppose you react this with sodium dichromate. If you react this with sodium dichromate in aqueous acetic acid, in acetic acid, CH3COO, what you will end up with is a ketone. Alcohol will be converted into a ketone by oxidation. Okay. Suppose you have this compound. Suppose it's a primary alcohol. CH2OH. What you will get is the corresponding carboxylic acid. Corresponding carboxylic acid, COOH. Okay, you will get the corresponding carboxylic acid. So this is the oxidation. So primary alcohol on oxidation will give you carboxylic acid. Primary alcohol, carboxylic acid on oxidation, vigorous oxidation. Oxidation. Okay. And tertiary, secondary alcohol. This is secondary alcohol. Will give a ketone. Secondary alcohol will give a ketone. Now, another important reaction of alcohol is conversion into ethers. Another important reaction is conversion into, here for example, I take this compound. I take this compound and react this with sodium hydroxide or sodium hydride.